Hello and welcome, guys. My name is Karam,
And I'm Ravindu.
And I'm Mark.
and we're going to be talking about machine learning and specifically how you can apply machine learning using Python in Azure Notebooks. So I'm just going to walk through the agenda here. So we'll be creating an Azure Notebook. We'll be finding data, and we'll be showing you how to and where to find data. We'll be doing what's known as data wrangling, which is essentially just putting the data into the format required to do further analysis and to run models. Then we'll be doing the analysis. We'll be looking at certain statistical parameters of the data. So we'll be looking at the distributions of the variables, the max, the min, all that sort of stuff. And then we'll be doing some machine learning. We'll be running a simple linear regression. And we'll explain as well what this stuff means as well further on in the video. Just first off, here are some resources that you can look at if you get stuck or if you want to know more. These are some really powerful resources. So everyone should be looking at Microsoft Learn, the Intro to ML with Python. This is some really good material, and you can do some tutorials there that will help you get up to speed on using Python with doing ML with Python. And for the general data analysis, here's some information, the PyData book, which is available on GitHub. It's a really good source of information. I would definitely recommend going there for any sort of questions related to data analysis. And then finally, we have just a cheat sheet for pandas. So this sort of stuff is really useful if you want to know how you can use pandas or how you can leverage pandas to split up your data, to manipulate your data. And this is really useful in the data wrangling process. And of course, you can Google cheat sheets for other libraries that we mentioned as well, and they'll likely pop up as well. Always a good resource to have on hand. Okay, so for the requirements, if you're intending to do this project, you'll need to create an Azure Notebook. You'll need to find another data set. We'll show you where to find these, but you can't use the same one that we use in this video. You'll need to clean that data set, and then you'll need to analyze it. And we'll be showing you how to clean and how to analyze data sets in this video. And lastly, you need to run a machine learning model on the data. So this can be either linear regression, random forest, or etc. Okay, so I'm going to pass it over to Ravindu, and he's going to explain to you what machine learning actually is.
So you may have heard this term called machine learning, but you might be wondering what it is. And it can be quite confusing in some degrees. So we'll start off with an example. Say I give you this bunch of information. So I say that there's a car that weighs 1,000 kilograms, and the fuel efficiency of this car is 40 miles per gallon. We're using miles here because it's an American data set. I also tell you there's a 3,000 kilogram car, and that has a fuel efficiency of 20 miles per gallon. And I ask you this question. So if there was a car that weighs 2,000 kilograms, how much do you expect the miles per gallon to be? Karim, do you know? What would you guess?
So guessing by the pattern here in the data, I'm going to guess 30 miles per gallon, just because the weight of the car is in between the two weights that we see there.
So congratulations, you've done basically a form of machine learning, which is basically finding patterns in the data and then using those patterns to predict things that you haven't seen before, basically. So what we're doing here, we have a bunch of inputs, and then you have a bunch of outputs. And we're trying to map the inputs to the outputs. So in the case here, the input is the weight of the car, the output is the fuel efficiency. And this is a certain type of machine learning called supervised learning. So there are other types of machine learning, such as unsupervised learning and reinforcement learning. But the most commonly used one is supervised learning. So that is what we'll be going through in this section of the course. You might also be wondering what the difference between AI, machine learning, and you may have also heard of this term called deep learning, what the differences are. Let's start off with AI. So artificial intelligence is a very general term that basically has to do with creating intelligent behavior in computers that basically tries to mimic humans. So that's a very broad, not very well-defined word, artificial intelligence. And then a subset of artificial intelligence is machine learning. These are more to do with the mathematical models you use for machine learning. So that could be statistical techniques or other machine learning models and algorithms that you use for this purpose of getting more intelligent behavior. And then deep learning is a subset of machine learning. Again, it's a specific type of specific class of algorithms that have to do with and these have been quite successful recently in things like images and analyzing images and language. We won't be able to get into deep learning in this course, but the linear regression type things that we'll go through is actually quite a foundational piece in things, and it's just a more complicated version of that deep learning basically is. So going back to our example, it's basically what we're trying to do is we're trying to create a function essentially that maps inputs x to the outputs y. So if you've remember your high school maths, you may have come across y equals mx plus c, which is the equation for a line. So in this case, what machine learning is basically trying to find the m and the c in this data set. So linear regression, trying to find the m and the c.
And just a reminder for anyone that's forgotten this equation, m is the gradient and c is the intercept on the y-axis.
Yeah, m is the rise over run, the slope of the graph. And you can think of machine learning as basically trying to find the m's and the c's. And it'll be much more complicated. So example, if you've got this just has a weight. So you could have m1 times x1, which is the weight. And if you have more variables, it'll be m1 times x1 plus m22 plus c. So that this can get more complicated, and then you can add nonlinear stuff, which is where things like deep learning come in. But essentially, you can think of it as a function approximator, and linear regression is trying to basically find the best fit line that fits the data. So it won't be an exact fit all the time, but we're basically trying to find the line that best fits the data. And you can think of deep learning. So in the case of more complicated things like images, we usually use convolutional neural nets for images. And you can still think of it as a supervised learning problem where the inputs are images of cats or dogs or images in general. And the output, you have the label, either a cat or a dog. And what the machine learning algorithm is trying to... So the images are consist of millions of numbers. You can think of them like the intensities of the different colors. And the function, the neural network in this case, is basically trying to find those m's and the m's and the c's in trying to come up with an equation that goes from the input numbers into the outputs, which will be things like the label cat or dog. So that's basically an overview of machine learning, and we'll go back into the notebook to see the car example in more detail.
Yeah, so we'll get straight into it. So we'll start by creating an Azure Notebook. I'm just going to switch over here to my my links. I'm going to get that link. So it's notebooks.azure.com, and put it into the search bar here. Okay, so we'll sign in here, and I'm going to use my university account. You'll be doing something very similar to what I'm doing currently. Login.uni.ac.nz. Okay, I'm just going to take this one here. Okay, great. So we're signing in, so we'll say yes to this. And so this is the first time I've signed in, so I'm going to have to create a user ID. And so here I'll leave my user ID as my university ID, and I'll save it. Okay, great. So I don't currently have any projects, and I would like to create one. So I'm going to click Create One. So we're going to call this Auto MPG, because I know what the dataset we're working with is going to be. Yeah, and you can call yours whatever you want to call yours. And I'm going to keep mine public, so later I can send the link to other people and they can view it. I'm going to go create. Okay, so then here in so here we can select a new to add a new notebook, which we're going to do, and I'm also going to call this Auto MPG, and I will be using Python 3.6, and then we'll go new, and now we've created a new notebook, which will open up just by clicking on it. Okay, great. So now we need to find the data. Okay. And one of the great websites we can go to is, I have a link to it here. So it's ICS, UCI. Was it
University of California, Irvine.
Yeah, okay. So we're just going to Google that so you can kind of get a point of an idea of how easy it is to find these data sets. Yep, that's that there. Okay, great. Yeah. So we'll just scroll down and look for our data sets. Here it is, Auto MPG. And we'll go to the data folder. I'm just going to copy the link here. So copy link address. I'm going to take that. So we're taking the auto, we'll actually have a look into it. We can actually have a look into it. So you can kind of see what it will look like. I'll open up an atom. So it's a .dat file, which might be a little bit unfamiliar, but we'll show you how to work with those. Just going to wait for the data to load up. Okay, great. So here we can see that we have columns and we have the data, and we'll have a look at it in our notebook. So we'll switch back to our notebook. I've still got the link copied, so I'm going to use curl. And so curl is a command line application that lets you download things from links. So essentially it transfers data from one place to another. And I'm going to use the exclamation mark here. In notebooks, you can use an exclamation mark to give Unix commands. So just as if you were on a Linux command line, you can use the exact same commands. So we're going to do that. I'm going to pull in that data set. I'm going to go Control-Enter to run that. Okay, and then while that's running, I will look for the next one. So I need to get information about what the data set actually looks like. So I'm going to go Auto MPG names. I'm going to copy the link address, and so that's running. Oh, that's finished running. I'll add to that. So curl. Okay, and then I'll run that. So I just press Shift-Enter and it opens up a new cell for me. And then we can actually check: do I have the files now? Yes, I do. So ls as the lists all the files in the directory command for Unix command lines. And we can see that we have autompg.data and we have autompg.names. So we want to know more about the data. So I know that the information is in the .names file. So I'll actually take a look at that. So we'll just use the cat command. So cat names, and then we'll run that. And now we can actually have a look at what's in the data, and where the data comes from. Yeah, so we've got the title here, sources, so this tells us where it was originally taken from, and also the dates that it was created. We can see where it was used as well. So let's have a look. I'm not seeing anything that's too useful here for the analysis purposes. So this is interesting. So we have 3 multi-value discrete values, and we have 5 continuous attributes. That will be interesting later on. And we can also see here that the different column names for the data, which we will actually have to add in because we don't actually have the column names in the .dat file. Okay, so now that we have the data set imported, we're going to put it into a data frame. But first we have to import the correct libraries. So the first one I'm going to import is pandas. So I'm just going to write import pandas as PD. So PD is just
the short form.
Yeah, the short form, and it's convention to import pandas as PD. And for now, I think I'll also import the matplotlib. So this is a plotting library, which we will be using to some extent. So matplotlib.pyplot, and we're going to import that as plot, plt. Okay, and we're also going to import Seaborn. Seaborn is a library built on top of matplotlib, and it allows for nicer visualizations. Yeah,
makes things look pretty.
Yeah, and we want to make some things here look pretty, and you'll be seeing how we do that in just a bit.
Seaborn is one word.
Yeah, Seaborn is one. Okay, Seaborn. There we are. Okay, so now we have a library, so I'm just going to run that using Shift-Enter. Okay, so now the first thing we want to do is we'll make a data frame. So I'm going to call our data frame dataset. And I'm going to use the Panda library. So we're going to use pd.read underscore CSV. Yeah. Okay, and then let's see. So we give the name of the file, which is autompg.dat.data. And then because it's not exactly a CSV file, we have to actually specify that's delimited using white space characters. White space. And we'll say true to that. Because CSV files are usually delimited using commas. So in this case, we have to specify that it's delimited using white space. And another thing that we'll do, I'll show you why. I'll show you why we're about to do what we're about to do. So I'm just going to show you what the actual file looks like, so you can kind of have an idea for why we're doing what we do. So .data. So I'm just going to have a look at the file here. Okay, so we can see the file here, and you can see that we have the columns, but we don't have a title. Okay, which is why I need to specify that the names of the columns. So the first one is MPG. The second one, what is it? Cylinders?
Cylinders.
Yeah. Cylinders. Yeah.
Displacement.
Displacement. That's a string. Displacement. Yeah.
And then horsepower.
Horsepower.
Weight.
Acceleration.
Model year. I would have an underscore just to.
Oh yes, yeah.
Oh, maybe not. Doesn't matter. Origin is where the car was made. And then car name is a string.
And we'll do underscore as well, just to keep consistent. Okay, great. So what this will do is give me all the column names in my data frame.
Yeah. So if you see the description, you can actually see what the columns are.
Yeah. So So essentially, if you wanted to know what the columns are, these essentially match up to these columns here. So it's MPG, that's cylinders, displacement. And I think you get the idea. So we're going to run that now. I'm just going to run that. It's going to make our data frame, and I'm just going to get rid of this.
Just we can override it.
Yeah, okay, we'll just do that. Okay, so now we have our data set, And with like the first thing we want to do once you have a data set is just have a look at it. So I'm just going to do dataset.head. And what that will do is it'll show me the top 6 rows of the data set.
5.
Oh, five rows of the data set. Okay. So it looks all right to me. We have the correct the names of our columns. We have all the data. It looks okay to me. So from now, we're going to continue. From this point, we're going to continue on. And we're going to have a look at the shape of the data set. So I'm interested in how many rows are there? How many columns are there? We can see how many columns, but how many rows is something that I'm really seen. And we're going to run that. So we can see that we have 398 rows in our data set and 9 columns. Okay. So then we're going to have a look. So one of the things that's really important in data science is cleaning. And now we're moving into that cleaning step. But first we have to identify whether or not there's anything that we need to clean. So in this, I want to check, are there any null values in my data set? So this happens if, data maybe wasn't recorded, and then they've used nulls to denote that the data wasn't there. But we want to get rid of those. So I've checked now whether or not there are nulls. There are no nulls, and I can continue on from here. Okay, so should we look at the description for the data set? Yes, I think that's probably a good idea. Describe.
Yeah, just to get an idea of what the summary is for the data set.
Yeah, so this is a little bit hard to understand. We'll be graphing some of this in a bit, but you can see just off the bat the count we saw before, 398 rows. We can see the mean for miles per gallon. So the average car has miles per gallon of 23 miles per gallon. We can also see the minimum. So these are the worst, gas guzzling cars, and these are the best, the max. And we can also see the quartile, interquartile range as well, and the upper and lower quartile.
Yeah. And the 50th one is basically the median.
Yeah, so the median, and this is the lower quartile and the upper quartile.
Something you can sort of see is like if the max is really, really big, you can see if there are any like obvious outliers, but we'll probably, graphing is probably a better way to see it.
Yeah.
Just to get an idea.
Yeah. Okay, great. So the next thing we're going to do is we're going to actually have a look at the types in our data set. So we're going to do types. Okay, and what this allows us to do is just to make sure that everything is as we expect it to be. So if we just quickly scroll up, we see that here we expect the miles per gallon to be continuous, discrete, and so on, and then the car name to be a string. And we would expect our data to look like that. I'm going to scroll back down here, and we can see that most of these are fine. Floats, integers, all of that looks okay. And the only problem is horsepower. Object here in pandas usually denotes a string, or strings are denoted as objects in pandas. And we see that horsepower is likely a string. So we'll have to figure out
some sort. Yeah.
Yeah. So
and if you look carefully at the describe thing, there are you can see 7 columns, and in the describe stage, pandas only describes the numeric columns.
Yeah.
So if you see there's 7, but there's supposed to be, if you look at the columns, there are supposed to be 8. Almost.
Yes. Yeah. Exactly 8, because we have 8 that's supposed to be numerical, and 1 that's a string, which is a car name. So that could have also given you an indication, but this is one way to check. So from there, we will actually move on to. So actually, first.
If you want to it is essentially, because if you go up here, it says missing attributes values. Horsepower has 6 missing values.
Ah, yes. Okay.
And if you actually have a look at the data, do you want to have a look at the data just to see how those?
Yeah, so I think we should probably do that next. So this is
they're essentially denoted as question marks.
Yeah, so we'll move on to the cleaning step here, because we'll have to remove some of the things that aren't correct in this. So what I'm going to do is I'm going to look at all the unique values in the data set for the horse column. And what that will allow me to do is identify anything that isn't, because as we saw, there is something that's not correct there. So I'm going to go horsepower. Okay, and then, so what this is doing at the moment is I'm referencing the data frame, and this is allowing me to look at one particular column, and now I'm looking for all the unique values in that column.
That's the method. So
okay, so actually, let me just. Okay, great. Okay, so as we can see, all of this looks quite what you'd expect. The only thing that looks out of place here is the question mark. This is not a number, and which is why Pandas decided to assign this whole column as a type string. So we're going to have to get rid of that. So to get rid of that, we're essentially just going to find it and clear it out. So all the places that happens, we move. We can't replace it because we don't know what the original horsepower was. So where we have these missing values, we're just going to remove the row. And there's only 6 occurrences, as we saw in the description of the data as well. So it won't be removing too much of our data set. So data set locate, and we're going to locate. We're going to locate all the places in the horsepower column where the value is equal to the question mark.
Oh, not equal to. Oh yeah. Yeah.
Oh, yeah,
so we want to keep the ones that
are. Okay, so not equal, exactly. So what this will say is, okay, if it's not equal to the question mark, keep it. If not, throw it out. So we'll run that, we run it. Now we have our new data set. Okay, so now we'll move on from there.
It's still a string.
Yeah.
So we should convert all the strings to a number.
Okay, yeah. So what we'll do then is we'll say dataset is equal to yeah, so I think I'll be able to. So we're going to assign something new to this column here. So we're going to say dataset, and then horsepower. Then we're going to do as type here, and we're going to declare the type as a float. Yeah. Okay. Great. Okay. So now we should be good. Just to check, I'm going to quickly run the same command that we ran before. So I'm going to go dataset.dtypes.
Yeah, you can also do describe.
Oh, no, callable. So there we are. Okay, so let's have a look. Okay, that's a float. Okay, and we're good to go now. So everything is now as we expected it. And now we can move on and look at the distributions of these variables in the data set. And so to look at the distributions, we're just going to use the inbuilt histogram function in Pandas.
Yeah, that actually comes from matplotlib, but they're all sort of connected.
Yeah, so matplotlib, a lot of libraries, a lot of graphing libraries are built on top of matplotlib. So Seaborn is also built on top of that, as I mentioned. Okay, and we'll do a 10 by 10 grid. Yeah, so what that allows us to do is we're essentially going to map out all the...
Basically create histograms.
Yeah, basically create histograms. You'll see what we... Okay, great. So, okay. So we can see here that acceleration looks to be a normal distribution. It's continuous. Cylinders is discrete, as was mentioned.
Yeah, it can be 1. Is that 2, 4, 6, 8?
Yes. Yeah. And so,
you can see they're relatively they look fine.
Yeah. So essentially what we're looking for is just to understand the data here. maybe this will inform some decisions we make later on, but for now, everything looks as it should. We can also see that miles per gallon is seems to be skewed to the left here. So the majority of your cars will have poor miles per gallon, so poor fuel economy, which is an interesting thing to note. Yeah, so I think we'll move on once we've seen that. Now we want to know what the relationship is between the variables. So, for example, if we take weight, what can that inform? Can that give us any information or tell us anything about, say, miles per gallon? Is there any sort of relationship there? So we're going to use Seaborn now, and we're going to use a pair plot. And we're going to call that on the dataset. Okay.
It's big.
Yeah, so make sure it's nice and large. The size parameter has been renamed to...
Yep, you can change that, but right now it should be working. It's just a warning.
Okay. So yeah, so we probably should actually ignore warnings, but for now, it should be fine. Okay, so it's quite large. It's a little bit difficult to see. But so you can see on the x-axis or along
y-axis.
Along the y-axis, you've got the names of variables, and along the x-axis you also have names of variables. So we can see that there are relationships between them. So let's say weight and displacement. So here there seems to be a positive relationship, and they seem to be somewhat correlated. But we're more interested in miles per gallon, so let's have a look at that. So we'll look at this down here. So yeah, of course that's correlated with itself. So an interesting one might be here, horsepower, displacement, and weight. So if we scroll up these three columns here, so you see there's a negative relationship between miles per gallon, horsepower, weight, and also displacement.
Yeah. So as the weight increases, the fuel efficiency, the miles per gallon increases, which means it's less fuel efficient.
Miles per gallon decreases, right?
Yes.
Yes. Yeah. Because
okay.
So the lower the miles per gallon, the less fuel efficient the car.
Yeah.
And as we can see, that is the case. So the greater the weight, the lower the miles per gallon. Okay, great. So I think we've understood that enough. I think we'll drop another little plot to make it more clear. Maybe this isn't as easy to see, but this makes it easier to explain correlations. But now we're going to create a little bit of a matrix here, using another one of Seaborn's functions. So I'm going to plot these subplots. And we're going to use the same, actually we're going to use 16 by 10, so fig size. Do 16 by 10. Okay, and we'll get the correlation matrix. Matrix, okay. And we'll be able to use a function built into pandas to essentially give us the information. It will generate a matrix for us.
No, we need the heat map. We need
yes. So Seaborn has a heat map that is quite useful in this case. So we can use the correlation matrix again. Copy it over. And we want to annotate it, so that will give us the correlation. Annotate. Correct. Annotate is equal to true, and then we're going to use
color map.
Yeah, so I quite like. Let's do orange and red. I quite like that. Orange and red, and then of course we have to show the plot. Okay, let's have a look at that. Okay, so it looks like So this is essentially the same information we saw above, just in a different format. And we can see that the color scheme here, so as you know, correlation ranges between -1 and 1, where 1 is positively correlated, so exactly positively correlated. So if you have, say, for example, let's see. So of course, every variable is positively correlated with itself, with a value of 1. So that's essentially just saying perfect correlation, right? Exactly. And then of course, you have the inverse of that, which is negative correlation. So if 1 goes up, 1 goes down. And that's true for the correlation between cylinder number, miles per gallon, displacement, miles per gallon, also weight and horsepower. So you'll see that as weight goes up, you expect miles per gallon to go down. And there's quite a strong relationship, as we saw above as well. Okay. Is there anything else we can say about data based on that?
I mean, you can. This is usually a good way to remove the ones that are obviously not related.
Yeah.
So in the car case, if we had a variable called color here, that you don't expect to be related to the miles per gallon.
Yeah.
So you would probably see a correlation of 0, close to 0.
Yeah.
And so we can use a plot like this to basically remove the ones that are not relevant at all.
Yeah. Yeah. Okay. So a correlation of 0 just says, this variable doesn't give us any sort of information about another. So knowing the value of 1 doesn't really help you figure out the value of another. Okay, so the next thing I think we'll do is, should we plot the miles per gallon?
Yeah, we can do that.
Yeah, okay. So I think we'll just have a quick look at the distribution of the miles per gallon. We've already had a look above, but this is just another way of doing that. So if you choose to, you can use this method as well. So this is another Seaborn it's another Seaborn function that we're using here. I'm going to plot the miles per gallon and just have a look at that. So yeah, as we can see, it seems to be skewed, and of course, there seems to be less fuel efficient cars than there are unfuel efficient cars. Okay, great.
So yeah, I think we can build a machine learning model now.
Yeah. Do you want to jump in on the spot?
Yeah, sure. So for our machine learning library, to create a machine learning library, to create a machine learning model, we're going to use the library called scikit-learn. So we sort of need to import that library. So we'll go import sklearn. So there's a few things that we need to do before we play with our model. So we'll import a couple of things, and I'll explain to you what they mean. So model selection, import train test split. So we need to divide the data set into a training set and a testing set. So that basically, the best way to think about that is the training set is basically think of it like a college, university exam. And the training set is basically what the model trains on. And the test set, you can think of it like the exam, that we don't show the model while it's training, while it's learning. We let the model train on the training set. So learn on the training set, and then evaluate how well it does on the test set.
Yeah, I think that's a pretty good analogy, because your professor wouldn't give you the test. They'll be sitting at the end of the year during the semester to practice on, because otherwise everyone will ace the test, of course, right?
Yeah. So you can basically, if you don't do that, you can basically memorize the final exam.
Yeah, and we don't want our model to memorize the final exam, because that wouldn't give us a very accurate sort of view of how good the model actually is.
So we'll use that to basically split our data set into
something happened there.
Oops, what happened? Okay. So I guess the first thing we sort of need to do as well is our data set. We need to convert it to the X and the Y. So the input and the output. So right now our data set contains both the miles per gallon, which is the answer to our question, and also the things we learn from, like the weight. So the first thing we'll do is we'll get dataset dot. We'll drop the empty miles per gallon column so that that the dataset does not have the x's don't have access to the miles per gallon column. So before we do the train test split, we will do that, and then we'll see the head of that. So you can see, oops, what did I do him from?
Oh, yes, yeah.
So we can see that the miles per gallon is no longer in X, and then we will also Y. Our Y will essentially be the miles per gallon. So dataset MPG, and then we can see the Y dot head. So that's just the first four values of the dataset. Yeah. And then we will do the train test split. On the x's, you need to give it the y's. And then you need to tell it how much of the data to use as the test. So the test size would, in this case, we'll use 20, maybe 30% of the data as the test set. So that means that 70% of 398 rows will be used as training, and then 30% will be used as the final exam, basically. And then we could, just to make sure that everybody has the same, we can set a random state so that we get the same answer every time. Otherwise, it'll be randomly split in the, it'll shuffle the data set and randomly split it just so that we're consistent. So we're running the linear regression model, so we also need to import that. So we'll import that from the same library. So from sklearn.linear model import linear regression. So so how do we know what sort of thing to import? Maybe it's probably good to go to the scikit-learn documentation.
Yeah, so going to the documentation is a really good way of learning. So if there's something that you want to achieve, or even if you just want to know what's possible, it's really good to just visit the documentation.
So you can, so there's the linear regression model, and you can, otherwise you can see what sort of other models are available as well.
Yeah.
So in this case, we're doing regression, which means it's regression because the per gallon number is a continuous number. In the case of like classification is basically like if there are discrete categories like cats and dogs, and regression is basically trying to predict a real number. There are obviously a lot of things here, but
yeah, so something you can look at if you're looking to get a little bit creative, and you want to think outside the box a little bit. You don't want to use a linear regression.
Yeah, there's a few examples there about regression, support vector regression, or all the other ones as well. So we'll be using linear regression. So we will import that, and so we first need to create the model basically. So that'll just be linear regression. And then we need to, after we create this model object, we need to fit it to our data. So we will fit it to the training data, which is the train X. By the way, another cool trick, if you press Shift and Tab, it'll come out of what you actually need to type in. So the first it expects is the X and then the Y. So we'll put the train Y. And then is it expecting anything else? We don't have to worry about the sample weight.
So by default it's none, which is why which was denoted in the docs there as well.
What did I do? Could not convert string to. Okay, so so we also have in the X, if you remember, there's the car name. So the machine learning models can only work with numeric data. So we need to drop the car name as well. So that will create just the numeric numbers. And then we need to run the train test split again. And now we should be able to fit it. So model.fit, and then that would have fitted our model. One thing we can do, if you go here to the linear regression, you can see that there's an attribute called coefficients. I think we should be able to see what it did. Model dot. So you can see these are the different weights it applied to each of the inputs. So in this case, the cylinders was weighted by negative 0.35. So these are basically the M's that the model learned from the data. And we can, after we've trained the model, so we've trained the model in this step, we can use that to predict on the test data set. So model.predict, and then give it the test x's. And predicted would give what the outputs of the model is. We don't have to. Another thing we can do is we can plot the predicted and the test y and the predicted, and then see if we got. Okay, that might not be the best.
I'll try scatter.
Is it plt.scatter?
Yeah, that's it.
Okay, so we can see that. But if we want some numbers, we do have the model.score.
Yeah, so this lets us quantify how good the model is.
Yeah, so we can have test x and test y. We give it the answers, and then it'll score the model, and then we can see that it got 80% accuracy. You can go here and check what score actually means. The R squared, basically how fit it is. So you can see it's relatively bunched up close together, the predictions and the actual results. So yeah.
Yeah, so that basically tells you how accurately, based on the other variables, the model can predict the miles per gallon. That's saying that sort of 80% of the miles per gallon number is predicted by the variables that we've used.
Yeah. So it is not. So if you want to use a different model, you can just change the actual model type here. To use random forest or whatever other model is. And the other things you could see is maybe some of these columns are not very relevant. Maybe you think the origin column is not actually useful. So we can create another model by dropping that column and seeing what happens to the model, if it increases or decreases.
Yeah, but I think we'll leave that for them to try out.
Yeah.
So these are things that you can think about, and also if you want, you can maybe apply other models because, for example, linear regression is quite a simple model, and the random forest maybe would yield better results, but that's something you can play around with. And then if you want to get, if you're looking to get further into this topic, have a look at how you can improve the score and how and those sort of things.
Yeah.
So if you're looking to do this project, essentially go through the steps that we went through with another data set. Not all data sets will be appropriate for linear regression. For example, if you have a data set with photos in it, it won't be appropriate for linear regression.
Yeah.
And then when you're going through and making a notebook, write down what you're doing at each step if you feel like it needs explanation, because we'd like to know sort of what you're seeing in the output. So what are you seeing in the correlations?
Yeah.
Why did you do that particular step?
Yeah.
That sort of stuff is that sort of stuff would be
Definitely
really great.
have more comments than what we had here.
Yeah, well, we were talking, so
Yeah.
you got the gist. But we won't be able to talk to you when we're looking at your books. So yeah, great. So I think that sums it up, and we'll wrap it up here. Thank you for listening, and we look forward to looking at your submissions.